Good morning, afternoon, Algebra 2 crew, or Math 2 crew. I call you Algebra 2 crew, Math 2 crew. It's all the same difference. Anyway, I'm going to start 8.7. I'm going to work out some of these practice questions. And remember, your job is to kind of see what I do and then model that and attempt to do the rest by yourselves. So good luck, and here we go. So number one, the diagram represents the expression x squared plus 4x plus 3 with the constant term missing. Complete the square by filling in the bottom right corner with 1 tiles and write the expression as a trinomial and in factored form. So we had just talked about this recently. And so with that bottom right-hand corner, if you look closely, yeah. So what we do now is we cut this up and we create that lower right-hand corner, the 1 by 1 tiles. And so those 1 by 1 tiles, if you remember, they were created because of these rectangles, the x rectangles, and there's a total of 4, right? There's 2 here and also 2 here. So a total of 4, and if you take 4 and divide it by 2, you end up with 2, and 2 times 2 is the number of 1 by 1s here. And that's how we came up with the method of completing the square, right? You take half the middle coefficient of 4x, take half that ends up being 2, and then if you square 2, it means you're multiplying 2 times 2, which gives you the number of 1s for the constant, okay? And that becomes a perfect square. Now remember, the square itself, if you look closely, when you look at the length and the width of the square, you have the dimension x by x, and then the rectangles are 1 by x, so there's a 1 here and a 1 there on this upper segment. This will be plus 2, and here this will be plus 2 as well. And so multiplying length and width gives you the area, which would be x plus 2 multiplied by x plus 2. So we call it the area model, because you're ending up with the area when you multiply length and width, which becomes x plus 2 squared. And you can FOIL, or you can just count the number of tiles. There's 1x squared, there's 4 x's, and then there's 4 1s. So there it is. That's what we were looking for. I hope that makes sense. Moving on to the next question. Complete the square, then factor. So they're not asking us to solve for w, they're just asking us to complete the square. Well, we learned that technique. We said that you're taking half of the middle coefficient. That's because the square needs equal amount of x rectangles on either side, right? And so half of 11 turns out to be a fraction, but that's okay. So negative 11 divided by 2 is negative 11 divided by 2. I don't want to make it a decimal. And then what I'll do here is I'll square that. So negative 11 squared. And 11 times 11 is 121. It's positive 121, right? Negative times negative. And 2 times 2 is 4. And so that becomes the value here. Yes, you can have fractions. If they're reducible, reduce them. In this case, this is not reducible. Yeah, I don't think it is. If you divide by 2, you end up with 6. No, it's not going to happen. Okay, so this is the answer here. That's a regular looking box. That's all right. Moving on. Okay, solve by completing the square. So we're going to solve this by completing the square. So the first technique, remember, is to isolate the first 2 terms of your quadratic equation. It's written in standard form. And so x squared minus 19x must be isolated, so we have to take 84 that's being added to the left side and now subtract it. So by subtracting that, we end up with this. Now, let's take the middle coefficient, negative 19, divide that by 2. Again, it's not divisible by 2, so it's going to remain a fraction. And now we're going to square that. So, and so I'm not afraid. Multiplying 19 times 19, why not just jump on the calculator real quick? Sometimes you need them. And that's 361. Okay. Over 4. Now, so what am I adding? I am now adding 361 over 4. Okay. So the factored form here becomes okay, so when you look at negative 84 and 361 over 4, the common denominator is 4. So with this expression, I'm going to multiply by 4. And so showing all my work, this becomes 84 times 4 is negative 336 over 4 plus 331 or 361 over 4, and so 61 minus 36 is 25, and so we end up with and so that's the simplified fraction once we add the numerator and then combine the denominator. So now let's take the square root of either side. And now remember, when you take the square root, you've got a positive and negative solution. So that becomes plus or minus. Let's use quotient property. And now let's subtract or add 19 over 2. So now we have 19 over 2. And yeah, I think it's going to simplify nicely. You can already tell. So we end up with x equals square root of 25 is 5, square root of 4 is 2, so we have 19 over 2 plus or minus 5 over 2. We have a common denominator, that's great. And so when we combine this, we have two solutions. We've got 19 over 2 plus 5 over 2. That becomes 24 over 2. And 24 divided by 2 is 12. And that mess, all that mess there was overrated because it turned out just to be the number 12. Okay. See what happens here. Now we have 19 over 2 minus 5 over 2, and that becomes 14 over 2, and 14 over 2 is just 7. And so lots of work just to figure that out. The comment I want to make about all of this work that we did was that you could probably solve this by factoring. Yep, I mean, you could solve this by factoring. And of course we didn't do that, but we're using completing a square, and so this was solvable by factoring. I'm assuming it was. I have to check it, but again, we're just using different techniques. So we have 3 techniques now. We can either solve by factoring, we can solve by using square roots, we could solve by completing a square so that we could use square roots. So there's 3 different strategies there that we've just discussed. Moving on, last question before I end the show, because we're going a little long, it's 10 minutes. Same idea, let's divide by 4, so I'm going to move faster without talking. And that's the show. Hey, like I always say, study hard and learn a lot. We will see you soon. Bye-bye.